So hello everyone, let us solve this problem. So this problem is in fluid mechanics. So we have here the diagram, the given, so the gauge pressure is equals to negative 17.1 kilopascal, neglect the weight of the air, and then find the elevation of E, F, G, and the deflection of our mercury. So this is Hg. So first of all, we need to find where the gauge pressure is. In a diagram, when you see this icon here, like a clock, this is the gauge. So the gauge pressure is above. So okay, since we know now that the gauge pressure is in here, above, we can now solve for the first, the elevation of E, F, and G. So let's first start with the elevation of E. We have the elevation of E. So as you can see here, E is in here, and then the liquid that is in the pipe E has the specific gravity of 0.7. So this is E here. As you can see, it does not touch the elevation of 15. So let's say this is the height. Let's assign point. Let's add point 1 here. And then let's say point E is in here. So then, solving the problems involving manometer, we need to sum up the pressure heads in terms of water. So in here, so summing up the pressure head, we need to keep in mind that when we are measuring the summation of pressure heads in water, when we are measuring the pressure head from above to below, that the sign should be positive. However, if we're measuring the pressure head or the summation of pressure head from below to above, our sign is negative. So let us try here the elevation of E. So since we cannot directly find the elevation of E, we first need to find the HE here. Let's assign this as HE. Okay, this is HE. So how do we get the HE? Okay, take in mind that for every point here, the pressure here is equal E. So the pressure would be just the same, or like there's just the same pressure in there. And then let's now solve for the elevation of E, or the height E rather, here. So let's start from the gauge pressure, which is, so again, let me first write down the formula for summation of pressure heads. So we have P1 over the unit weight of water, which is in kilonewton per cubic meter. We're going to use that value. So as again, neglect the weight of air, and then we'll just move to 1 to E, plus the pressure head at 1 to E. It's just the same here. And then from here, the pressure from the outside is P, let's say E, over the unit weight of water in kilonewton per cubic meter. So then we need to substitute the value for the pressure for the gauge pressure is negative 17.1 over 9.81. We have here kilopascal. So when we do a dimensional analysis, we have here kilonewton over cubic meter. Let's say we do a dimensional analysis on that. We have kilopascal. Kilopascal can also be written as kilonewton over square meter, and then kilonewton over cubic meter for the unit weight, as you can see in here. and then we can cancel out the kilonewton, and then the square meter here, and then for the meter cube it's just meter, and then we move the meter up, which will give us the pressure head. And then on our pressure head from 1 to E, so we have the pressure head of 1 to E. We have the specific gravity 1.7, or let's say the pressure over the unit weight of water also. However, let me first elaborate the formula. We have here 0.7 times 9.81. Since it is a pressure, in our formula, the pressure is equals to unit weight times the pressure head. So pressure head is equals to pressure over the unit weight. So first we're going to find the pressure here, the pressure. Since our unit weight here is in water, and then pressure 0.7 times 9.81. Again, this is kilonewton over cubic meter multiplied by our elevation, or the height, h, e, over 9.81 kilonewton over cubic meter is equals to, again, the PE here, as you can see, it is a free surface. If there is a free surface, automatic, that is 0. The pressure there is 0. The gauge pressure there is 0, since it is in free surface. The pressure there is just 101.325, or the 1 atmospheric pressure. So it's just 0, since we are dealing here gauge pressure, and then we have 0. So as you can see, 9.81, this can be cancelled out. We can compress the formula into negative 17.1 kilopascal over 9.81 kilonewton over cubic meter plus 0.7 times the height, E, is equals to 0. Again, by assessing this equation, we can provide a formula that we can use later on. We have the initial pressure, or pressure at 1 over the unit weight of water, plus, instead of using the pressure head here, we can use S, or the specific gravity, times the height, or the pressure head, or the height of the fluid. So it's equals to P E over, like that. So it's just the same. And then we can find the value of our height of E. So let's say the height of E. We have here, so we can transpose this to the other side, and then divide 0.7 to negative 17.1 over 9.81, and then divided by, since this is positive, transposing this to the other side will give us a negative 0.7. We have 2.49, or around that, up to 2.5. There's the height here is, the height E here is 2.5 meters. However, that is still not the elevation. So to get the elevation of E, we need to analyze again the diagram. Elevation 12 here, and then we have elevation 15, and then we've acquired the height of E is this. So how do we get elevation? So since we acquire the value here, and then our liquid is just here below the at the bottom, or the let's say the bottom limit of our HE, or the height of E, we can subtract the elevation of 15. So elevation of E is equals to 15 meters minus the height of E, which is 2.5 meters, it is equals to 15 minus 2.5 is equals to 12.5 meters. So this is the elevation at